Hi everyone! In this video, we're going to be talking about Unix/Linux file systems and file security. Let's start with the file system structure. Unix and Linux have one unified tree structure, and so everything starts at the root, which we just write as a /. Here you can kind of imagine your files and folders as this big upside down tree with the root at the top and then the branches going down. Each user gets a personal quote unquote locker, if you will, inside the /home directory. On macOS, that's /users. So, for example, if your name is Alex, you might have /home/Alex, or if you're Trisha, /home/Trisha. And you might be wondering why we do this. It simply keeps the user files isolated and prevents a lot of clutter in the root directory. So now we have a bit of a special case, which is the root user's home directory. And it's important that you don't confuse /root with simply the /. Also, something to note about the root directory is that it's only accessible with admin rights or super user rights. It is dangerous to work here unnecessarily because any mistake that you might make could affect the entire system. So you never want to be doing, your daily work in root. The root account can also override all permissions. I'd like you to pause the video for a second and try to answer this on your own. Then we have bin, which stands for binaries, and that just is a special type of file. Binaries are special files that are programs that your computer can run, and they're accessible to all users and include basic commands like ls, cp, mv that we talked about. But without the /bin, the system can't boot or run these basic tasks. And sometimes /bin is just a shortcut, which is also known as a symbolic link to /usr/bin, which also stores programs. So what do you think would happen if the /bin were deleted? Well, the operating system would become unusable since you wouldn't have those core commands like ls and all of that. Next, we have the USR directory. For the longest time, I thought it was just short for user, but it actually stands for user system resources. And it houses the non-essential but still widely used programs and libraries. So it might contain Office programs or web browsers and programming tools. So most of the time, if you have installed applications on your computer, they're probably somewhere under the USR directory. And then if you type ls-l/usr, it's going to show what's in that directory. All right, now we have a special directory that's reserved for admins called SBIN, and that stands for System Binaries, and it includes tools for booting, repairing, and networking. Most of the time, you're not going to need to use these, but it's worth knowing that the SBIN directory exists. Then we have the /mnt directory, which is used to mount, or in other words, connect extra storage. So think plugging in a USB drive or a DVD player, although I don't know how common that would be nowadays. We do not really use DVDs. But by mounting, we're able to make the things on the USB drive or whatever external storage device we might be using accessible from a certain folder on your computer. For example, it might be under mnt/cdrom. It is important to note that you need to unmount before unplugging whatever external device you've plugged in, or else that could lead to data corruption. /media is the modern place for removable devices and is recommended by FHS, which is the File System Hierarchy Standard, because it allows for auto mounting, but you can also use the /mnt for manual or temporary mounts. Now, there are a lot of times when you might have a file that you don't really want to use for the long term. And so we have this thing called the /tmp directory, which is kind of like a scratch space for temporary files. What's important to know about it is that it's automatically cleared at reboots depending on your distribution. And you might see it used by programs like editors or installers. Then we have the etc or etc directory, and this stores system-wide configuration files. So it's where the operating system and installed programs are able to store their settings. So it's kind of just like configuration files that tell the computer how to behave. We do have some key files. For example, the fstab tells you mount information, the passwd stores user accounts, shadow stores encrypted passwords, etc. For this course, you don't need to know these specific etc. files, but if you're curious about it, there are some listed on the screen, so you can feel free to check those out. The lib directory contains libraries or pieces of code that all of the programs use and share so that they don't all have to include their own copies. And this just saves space and makes updating things easier. And I briefly mentioned symbolic links. So some files here are shortcuts or symbolic links that simply point to the real files elsewhere, and it's just kind of like a convenient shortcut again. The boot directory is pretty straightforward. It simply holds the files needed for the computer to start or boot up, and usually you don't need to touch any of these files. The /var directory is a directory to store variable data. That might be things like logs or printer queues. And what's special about it is that it is constantly changing in size. So, for example, you might have /var/spool/mail for storing incoming mail, or another directory for holding printing files before they're actually printed. There's also one called /var/log, which is really important for troubleshooting. However, a pitfall of the var directory is that if it gets filled up, then the system might freeze or have issues logging in. When you go to name files and directories in Linux, it's important to note that Linux is case sensitive. If you name a file with an uppercase letter and then you make another file with a lowercase letter, it's not considered the same thing. And then also when you're naming files, avoid white space. So, for example, if you wanted to have a file called data samples, you wouldn't want to name your file data space samples.txt. You might do data-samples.txt or data_samples.txt. Also, it's important to note that the / character is a reserved symbol, and so it cannot appear in file or directory names. We've also got a few shortcuts that are special. So the tilde means the home directory. Then we have a single period, which is the current directory, and then 2 periods, which is the parent directory. And that can also be quite helpful when you're navigating. For example, if you want to change a directory and you don't want to have to type out specifically what the parent directory is, you could just use the 2 dots shortcut. To find any file or directory, we use what is known as its path, and every folder and file lives in one big tree, again, as I mentioned earlier, that starts at the slash, which is the root, and then each directory name is separated by a /. So you can kind of think of it as like a folder inside a folder inside a folder. We have two things. One is an absolute path. So that would be that full sequence all the way from the root. And then we have relative paths, which are just relative to your working directory or the current directory that you're working in. It's kind of like comparing a GPS to local directions. GPS would tell you exactly what freeway and all of that, what you're going to do specifically, as if you had no clue about where you were. Whereas local directories, say you ask a friend how to get to the store and they say, oh, drive by the strawberry stand and then turn left, and then you'll see a big building. They're relative to where you currently are. Again, if I type ls/, I'll be able to see all of the main directories that are in my root, including the ones that we talked about, like the etc., the bin, and so on. Now, if I want to look at my home directory, what I can do is type cd and then a tilde, enter. That's going to bring me to my home directory. And then pwd means print working directory. So I'll be able to see that I am at my users/Devin. Now, if I want to see what is in my home directory and I want to see it with the extra details and showing hidden files, I can type ls-la, and as you can see here, it's going to show me all of the file permissions and then also include all of my hidden files that start with a dot. All right, we've got something called the pwd command, which is really useful because it allows you to print your current working directory. And this just helps you know where you are so that you can reference it when running any other commands. As mentioned earlier, there are the single dot and double dot shortcuts. So for example, if you wanted to list files in your parent folder, then you could use the ls command combined with the two dots instead of providing the full path to your parent folder. Then we have change directory, which is oftentimes used in conjunction with pwd, just because if you change your directory and then you want to confirm that you are in fact in the directory that you had intended to change to, you might run pwd. Then we've got things called wildcards. So the asterisk means matching any string. If you wanted to, for example, find all of the files with a .txt extension, then you might say ls**.txt, and that would list all of the files with that extension in it. Then we also have the question mark wildcard, which is to match one single character. In this example, ls list question mark would list every single file that starts with list and then ends with a single character. However, it's also important to note that, for example, the rm command, which is to remove a file or directory, could be very detrimental if you say ran rm asterisk dot and then some file extension name, because then that would mean that you're removing all of the files with that extension from the directory. Then we have the mkdir, which is used to make a directory. And then we have rmdir, which removes directories that are empty. And then we have rm/rf, which recursively removes things, which can also be dangerous. What I mean by recursively is that, for example, if you ran rm/rf on a project containing your entire folder, it wouldn't just delete that parent folder, it would go through to every single level of all of those subfolders, all the way down to the individual file and remove everything inside there. So for example, if you're at the root and you type rm/rf/, that might not be a good idea because there's a good chance that it will just wipe your entire system. If you're watching this on your laptop, I'd recommend trying out these commands on your own just to see how they work. If we want to copy or remove specific files, we have CP, which is for copying, and then RM, which is for deleting or removing files. We also have this greater than sign. I'll draw it out here. So a greater than sign is essentially a way to redirect an output into a file. Specifically, how the syntax works for all of these is to copy a file, you would write CP, then the name of the old file, and then the name of the new file. To delete a file, you would simply type rm and the name of the file. And then, for example, if you wanted to create a file that lists the contents of the etc. folder and write them into a file called etc.files, then you would write out ls slash etc., which is what would normally give you the list of what's in the folder, then that greater than sign, and then etc.files. So instead of listing the results in your terminal, if you go to etc.files, then that's where the output would be. So if you'd like to try these commands on your own, again, I encourage you to do so just so that you get familiar with how these work. Then we have the mv command, which simply moves files between directories or can also rename them. However, unlike the cp or the copy command, mv does not keep the original file. So if you want to move a file, you can simply write mv, the name of the file, and then after that, the path that you want the file to go into. If you want to rename a file, you can simply write mv, the name of the old file, and then the name of what you want your file to be. Now, in terms of file operations, while I explain them, I thought it might be helpful to just see a couple of examples. So again, let's say that I wanted to create a new file. So using touch, and I want to copy that new file to, let's say, so new underscore file dot txt. That's the file I want to copy. And I want to copy it to a file called copy dot txt. Hit enter. That's going to create a copy of whatever the new file txt has into a file named copy.txt. Right now, both files are empty. Let's say that I simply want to rename the file called copy.txt. I can type mv copy.txt and then the name, say renamed.txt. And that's going to rename the file called copy.txt. Say then that I want to delete the file that I just made. Again, I would just type rm and then the name of that file, which is renamed.txt. And that's going to get rid of that file. So if I wanted to make a directory, instead of using touch, I would use mkdir and then say my directory. And all of the other commands would be very similar, except say that I make a directory called my directory and I want to copy the directory. I would do the cp like I would with a file, but then add -r, which is for recursive. I would be copying this directory recursively, which again means just that every single subfolder all the way down to the file level would be copied as opposed to just that parent directory. All right, I'm also going to just remove that directory now. Whoops, rmdir for remove directory. And there we go. The reason I got this error was just because I did rm, but you need rmdir because you're not removing a file, you're removing an entire directory. Now let's talk about how we configure file permissions for security purposes. So there are three main permissions that are important to note. Firstly is read, so literally being able to read the file, and that's abbreviated by a lowercase r. Then we have a lowercase w, which stands for write, so that means you can edit the files, make changes. And then we have the x, lowercase x means execute. So if it's a program, for example, then that means you can run the program. Now, syntactically, this just means that if you wanted to use the ls command and say you ran ls -l, that would give you the long format with all of this permission information listed when it lists the files. So in this case, underlined here, you can kind of think of splitting it by every three. So you have read, write, execute, read, and then no permission, execute, and then read, no permission, and execute. Now you might be wondering, okay, well, why are there three different read, write, execute triplets? Well, the first triplet is for owner permissions, the second is for group permissions, and then the third is for the permissions of others. We've also got something called chmod, which just means that you're using the file name and are doing something to it. So, for example, chmod and then a plus sign and the lowercase letter x would mean that you are executing that file. And again, you do need to have the proper permissions in order to read, write, or execute, respectively. When a system administrator creates a new user, they also assign the user something called a group ID, or GID for short. And what a group is simply a collection of users. Sometimes you might want several people to work on the same files. For example, a project team might all need to edit the same documents or might all need the exact same permissions. And so by putting everybody in one group, you can set the file's permissions one time, and then everybody in that group gets identical access. So again, we have 3 sets of permission for each file: the U, the G, and the O for user, which is the file's owner, the group, which contains the members of the file's group, and then others, which is everybody else. Now, what I'd like to do is just show a little bit of a visual example of how file permissions work. So, say that I want to create just a test file.txt. I can type touch test, I'll do an underscore file.txt. Okay, I have that file. Now, if I want to see what the permissions are, I can type ls-l and then the name of that file, which is the test file.txt. And right now it shows that we have reading permission and I also have the writing permission, but not the execute permission. So if I want to do that, I can go into change mode by typing chmod plus x, and then the name of the file, which again is test underscore file.txt, hit enter. And now what is going to happen is I'll use my up arrow key to get to this command that I recently ran and run it again. And now, as you can see, I have that execute permission denoted by that lowercase x. Now, there is a numeric way to do this. So instead of letters, we can use numbers with each permission having a value. So, for example, to only read is a 4, to only write is a 2, and to only execute is a 1. And then we can add them up for each of the user, group, and others. So, for example, chmod 777 is going to allow all 3 permissions, again, that's the user, group, and others, to have full read, write, and execute access. Now, this numeric mode is faster once you get the hang of it, but it also can be a little bit more challenging. So symbolic mode is usually easier to learn. Again, I would like you to try out these commands on your own. All right, that pretty much concludes our video. There are a few summary slides that are on the PDF in Canvas, but to keep this video succinct as possible, I'll let you take a look at those summary slides if you choose to do so, and I'll just show them really quickly here. So we've got the command summary, and that's it. Okay, everybody, thank you, and have a great rest of your day.